Alright, everyone, welcome to Season 2 of Physics with Arif. In this episode, we'll be covering Unit 2.01, Speed, Velocity, and Acceleration. First things first, before we learn this topic, you'll need to know what are scalar and vectors. Scalars only have a magnitude or size, for example, mass, speed, or distance. Scalars are basically the complete measurements that we learned in Unit 1. About vectors. Vectors are kinda like scalars, but has a direction included with it. For example, 10 meters a second, that's a scalar. Now if you go just a little BAM, and then a BAM, now it's a freaking vector. Easy as pie. But sometimes people use positive or negative signs to indicate the direction. For example, 10 meters a second, a scalar, and now a freaking vector. Or even, now a freaking vector. The arrow, positive or negative signs are all the same and don't really matter, but arrows are way cooler. Let's talk about speed. Speed is calculated through distance over time. This equation is actually for average speed because the speed of something may vary over time. As you notice, there isn't a direction indicated by an arrow, a positive, or a negative sign, which means that the speed is a scalar. Velocity. Velocity is the vector version of speed. That means that it's speed, but it has to have a direction attached with it. Example of velocity. The speed of this MRT train is 10 meters a second, but is heading towards hell. So, the velocity of this MRT train is positive 10 meters a second towards hell. Acceleration. Acceleration is the change of velocity over time. It is calculated like this. A equals to triangle V over triangle T. The triangle indicates change. A is acceleration, V is change in velocity, and T is change in time. Example. Let's say a car is fully stopped. The car then drives off with the speed of 3 meters a second in the first second. What we are trying to calculate is the average change in velocity. How to calculate? So, with this table, we'll first have to take the initial time, which is 0, and minus it by the final time, which is 4 seconds. 0 minus 4 is 4 seconds. Then, we'll have to take the initial velocity, which is 0.5. How to calculate? So, with this table, we'll first have to take the initial time, which is 0 seconds, and minus it with the final time, which is 4 seconds. So, 0 seconds minus 4 seconds is 4 seconds. And then we'll have to take the initial velocity, which is 0 meters a second, and minus it with the final velocity, which is 12 meters a second. So 0 minus 12, which is 12 meters a second. So acceleration equals to 12 meters a second over 4 seconds. So acceleration is 3 meters a second to the power of 2. Now take note that acceleration is represented through meters a second and a little 2, a little floating number 2. Now, that's it. I think. Thank you for listening, and come back next time for episode of Physics with Arif.